All right, let's talk 4.10. Today we're talking about functions. Okay, functions. Is it a function? All right, vertical line test, domain, and range. Okay. Don't worry. Don't freak out when you hear all those things together because I know some of us may have some bad flashbacks to algebra two, but that's okay. We're gonna maybe not bad, maybe just some flashbacks. You know, this is going to be a little bit different, obviously, just like everything is in this class. Okay, we present it in a different way, so hopefully it's not as bad. All right. Recall that a function must match one input to only one output. Determine which of the following represents a function. All right. Well, we look here. The biggest question we got to ask ourselves: does x repeat? That's how we really determine. Does x, since x is not repeating this first one, I would say yes. Okay, and because not repeat. Now, x cannot repeat, but y can. Because there's these two negative fours for output, that doesn't matter. Okay, only x cannot repeat. Y is. So now they flip it. And now y's become our x's or x's become our y. So this, if you look here, -4 repeats and is the x, so it's a no because -4 repeats. That's it. Use the graph of function to complete the table, estimating what necessary. Does the graph represent a function, yes or no? All right, -2. So basically, here's what I want you to do. Figure out the y values given the x values. Okay, go find on the graph. Like I'll start you off with -2. -2 is about 0. Okay, so go ahead and try that and pause the video. All right, so here's what I came up with: -3, 0, which we did together, -3, -6, 3, 0, which is right here, 1, comma 3.5. If you said like 3.2 or something along those lines, anywhere in between 3 and 4, really, and then -1, comma 5. Does this graph represent a function? Yes. X does not repeat. All right, let's keep going. What are we talking about today? So, do you know how to apply the vertical line test? And where you look on the graph to find the domain and the range. All right, so vertical line test is a test that we use to determine if a graph represents a function or not. Remember, in order to pass the vertical line test, I'm going to take my pencil and just run it across the graph. Okay, I'm going to run it across the graph, and if my graph hits my pencil more than once, then it fails the vertical line test and it's not a function. So if you look here, this first one, if this is the red line represents my pencil, and if I move that red line around our graph, the graph would only hit the line once. So this would be a yes. The second option here, you can see that the graph hits my red line twice, so this would not be a function. Okay. So apply the vertical line test. So again, I'm going to take my pencil. I wonder if I can create something here. Give me 1 second. This is kind of something. We'll do our best here. So imagine that's a pencil, okay? So I'm going to take my pencil and run it across my graph. This graph is only hitting my pencil just once, so this would be a yes. Same idea, run it across this line. Holy buckets, it only hits this once. This is also a yes. Even though it's a horizontal line, don't let that fool you. All right. Our next C and D. Part C, well, if I put my pencil over this straight line, this vertical line, boom, it hits it a lot of times. It hits it infinitely many times. So this is an example of a no. If I do the same part with D, look, it hits it twice. So this is another. keep going. So it gives us this, says use the function y, or excuse me, f of x equals square root of x minus 2. Graph, and its graph determine the inputs and possible outputs of this function. So this is called a radical function because, excuse me, it should say that in your margin there. It's a radical function because our x is underneath the square root. Okay, remember this little square root is called a radical. All right. If you look at the graph from left to right, you notice the smallest x value graphed is 2. And then if you look, the inputs continue to increase. So x can be any number greater than 2. For your y values, if you look, it has this nice little arrow there. The outputs, the smallest possible y value is 0, because at the line y at this x at the x-axis, y equals 0. And then that goes on to infinity and continue to get bigger and bigger. So y should be greater than 0. So what are we finding here? What are we talking about? Well, we're talking about something specific. And what we're talking about is our domain versus our range. So our domain, we read from left to right. Okay, it's all of your possible inputs. Your range is from up to down, bottom to top. All right, it's all of our possible outputs. All right, so domain is input, range is output. Okay. So this function is called a rational function. I think when I say rational, I think ratio. Is it important that you know the names of these functions? No, but I want you to at least hear the names, all right? And understand that those names exist, okay? So this is called a rational function, and we want to determine the domain and range. So our domain, let's talk about our domain first. Remember, domain is all of our possible inputs, okay? Well, if you look here and look at this graph, your inputs, if I read it from left to right, this goes on forever here, okay? And it looks like it stops, it hits this invisible asymptote here, and then it picks back up again, our graph does, and goes off to positive infinity. So really, it looks as if the only value that we cannot have for x is at this imaginary vertical line. Okay, so our domain, well, what can x not equal? Domain x cannot equal 3. That's the only restriction that we have. All right, we're not going to use interval notation. We're going to use inequality notation here. Okay, and I think that's sometimes easier for people to understand. All right. Range, we read from bottom to top. Well, if I start at the bottom here, clear this out. All right, range is our output. So if I start at the bottom here, well, if you look right here, that's going off to negative infinity. And then all of a sudden my graph is like tailoring off. It's just evening out like that. And it's doing the same thing here. And then it's going off to positive infinity. So if you look here, the only restriction on y that we have is that y cannot equal 0. Right? Notice that these graphs do not cross that line here. They will approach it, but never actually cross the line. All right, that's important. This will never cross that actual line. Okay. And for domain and range, that's all we want you to write. Okay, and stuff like that. This is a little bit easier to see. Okay, the domain, our possible inputs or our x values. Domain, I read from left to right. Well, my smallest possible x value is -4. My largest possible x value is 4, and x is in between the two of them. So boom. Now I throw the equal to sign underneath there because this is a closed dot. Okay, it's a closed dot. I can include those points. Range, I read from bottom to top. The smallest possible y value is 0. The highest possible y value is 4. And y is in between the two of them, and y can equal the two of them, just like that. So the range is from 0 to 4. Are there going to be times where this will not be equals? Yes, there will be times like that, and those times will happen when these here are open dots. We're going to do the connect portion as a whole class.